All right. So 2.9, using the math class. And I will say, as a spoiler alert, I guess, in this, we'll be learning how to use different methods that exist inside the math class, but they may not always be the most convenient methods. There may be methods that exist that are easier to use. These are just the ones that have been chosen. Okay, so we'll work through this. Please ask me questions along the way if you have them, but we're starting off by using the Math.random method that allows you to access random numbers. So starting off, it says games would be boring if the same thing happened every time you played the game. Games often use random number generators to generate different possibilities. And random number generators can be different. Different programs may use different types of random number generators. Today, specifically, we're talking about the random number generator within the math class. So it says you need to know how to use the Math.random method to generate a random number. And that's what we're going to go through today. It says there are lots of mathematical methods you might want to learn how to use in different programs, including the Math.abs, which stands for absolute value. Okay, from Algebra 1, as early as Algebra 1, we've learned about what absolute value is, and it's the distance from 0 on a number line. So absolute value is always positive. The way it explains it here, it says it calculates an int argument, which is of the value of a number without its sign. Okay, so just the number, how far it is from 0 on a number line. It says, for example, if you try to find the absolute value of -4, it's going to return a positive 4. Okay, Math.abs, and then -4 inside the parentheses is a sign, is going to be equal to positive 4. It says these methods are in the math class defined in the java.lang package. These are static methods, which means you can go ahead and use them without writing a new constructor and a new object. You can naturally use them just by importing this package. Okay, so if you were to type in math.random, you're able to access it without actually creating an object first. Okay. It's just reiterating what a static method is, and static methods are called using the class name and the dot separator followed by a method name. You don't need to create an object, as I just mentioned, and you can use class name, dot, and then whatever the method name is without actually worrying about creating an object from that class. It says the Math.random method returns a number greater than or equal to 0.0 and less than 1.0. So it's going to return a decimal. So Math.random returns a double, which in many cases, if we're trying to find a random number, most of the time, especially in beginner level programs, we want to return an integer. So we're going to return a number 0.0 to 1.0. It could be 0.3, 0.4, 0.5, so on. It says try out the following code below and print it out. So we're looking at this. We have our main method, and we're printing out a random number. If we just type math.random, it will randomly print out a number between 0.0 and 0. It says less than 1.0. Doesn't say less than or equal to. Okay, so we'll have a number printed out. Let's go ahead and run it. And it prints out two random numbers. Notice the length of each. We have 0.15585818813, a long number, as well as 0.802. Let's run it again, and we'll get different random numbers. 0.223948. 0.46199. All right. So every time we run this, it's going to report back a random number, and it generates it pretty quickly. And there's different ways that computers could generate random numbers. And as I mentioned the other day briefly, you can generate random numbers based off of the time of day. You can generate random numbers based off of where your mouse pointer is, how long you've had your this page open. There's many factors that can go into it, even multiple factors. So, we're not going to necessarily talk about the how right now. We're just going to deal with this method that generates a random number, and we're going to use it. Okay. It says you can use Math.random and a cast to integer to return a random integer, which is what we'll probably want to use it for. It says we can have a starting and ending value. The code below will create a random integer from 0 to 9. Remember that casting a double value to int will throw away any values after the decimal point. So if we had like 0.8469, right, what it would refer to is whatever 0.8 is. If we're referring that up to an integer, right, that would round up, okay, and that would give me a 1. So it says run the code below several times to see how the value changes each time. How could you change the code to return a random integer from 1 to 10? Modify the code and see if your answer is correct. Try moving the parentheses from around math.random times 10 and run the code several times. What happens? So let's just look at this. So I have system.out.println, and I'm printing out a random number. We're multiplying it by 10 because when you multiply a number by 10, right, a decimal by 10, that allows you to move the decimal place over 1. So by moving the decimal place to the right 1, that will give me a number that doesn't start with 0. And that allows me to then cut off anything after that decimal by casting it to an int. So if I run this, right, notice that I get 1. If I run it again, I get 8. If I run it again, I get 6. If I were to take away multiplying it by 10, I would get 0 every single time I'd run it. Okay, so if I had like 0.33, it would cut off everything after the decimal point. So I want to move the decimal point to the right 1. And we know if we multiply anything by 10, that moves the decimal place to the right 1. So rather than dealing with a double, we've now cast it as an integer. Now let's look at what it wants us to do. It says, how could you change the code to return a random integer from 1 to 10? Okay, instead of 0 to 10. Think about this. Maybe if we add 1 on the end, because right now we're doing 0 to 9, right? Because the random numbers are going to happen from 0 up until 1.0. So if we add 1 to it, now we're dealing with random numbers from 1 to 10. Let's test to see if this is right. Okay. And now I'm able to do that. So if I run it again, I have 6. This gives me 6 again. I'm running it again. Now it's 7. And I'm just selecting a random number. We're multiplying it by 10, which makes it a number that has at least one number before the decimal place. We've added 1 to it, so it starts at 1. So really, I'm finding a random number from 1 to 10. That's what that code does right there. Okay. We've started there. It says math.random, just a note, returns a random number between 0.0 to 0.99. That's why we added 1 to it. By casting this as an int, finding the random number, multiplying it by the range, and then adding the minimum, what we want the minimum value to be. That moves the random number into a range starting from a minimum number. Okay. It says the range is whatever the max number is minus the min number plus 1. Okay, the max number minus the min number plus 1. So we wanted numbers 1 to 10. That was what we were trying to accomplish. So the max number would be 10 minus the minimum number, which would be 1. Okay. And then we add 1 to it once it's done that calculation, which then makes that number 10 minus 1 plus 1 is 10. This is just a little formula they've written up for you. Okay. The max number minus the min number plus 1. That's what we would put inside of this. All right. That's important for our next few examples. So we've looked at this. We've already used a random number. We've already determined how to find a range 0 to 9 by just multiplying it by 10. If we wanted to go 1 to 10, right? 1 to 10, we add 1 on the end, just as our example showed right here, right? If we want the range 5 to 10, okay, we want the range 5 to 10, including 10. Remember that our formula was take the max number, subtract the min number, and add 1. So the max number minus the min, 10 minus 5, gives me 5 plus 1 equals 6. Okay, so we multiply whatever the random number is times 6. And then we're going to add, we're going to add 5 to it. And 5, once again, we looked, is the min. That's where that number came from. Okay, seems kind of confusing. You don't have to know the ins and outs of this. Don't get caught up too much of it on this. It's not too important, but that's the formula we're using, the max number minus the min number plus 1. All right, so looking at this again, it says the range is -10 up to 9, including 9. So what we would do is, it says the range is doubled. So we take 9 minus, so the max number is 9, minus the min number. 9 minus -10 gives me 19. And then I'm adding 1 to it, which is 20. Okay, so I'm multiplying it by 20. And then the minimum that I'm looking for is -10. So I'm multiplying the random number times 20, and I'm subtracting 10 from it. All right. I've already completed some of these just because I wanted to speed through this, because I wanted to be able to hopefully fit all this in. I might not be able to fit everything in since we were trying to fit this in 45 minutes today. But it says, which of the following would be true about 40% of the time? The reason I've determined that Math.random is less than 0.4 is because we have a 60% chance every time we run it, a 60% chance of it being over that number. So it'd be 40% chance less than 0.4. Okay. Math.random over 0.4 would be a 60% chance. And the odds of it would be very low odds of it falling on 0.4, right? Very low. Okay. Which of the following would return a random number from 1 to 5 inclusive? The reason why I've determined this, right? I've multiplied it by 5 and then added 1 to it because that starts the counting at 1 and it would go up to 5. Okay, we've added 1 to the number. It says, which of the following would return a random number from 0 to 10 inclusive? The reason why I just multiplied it by 11 and chose that as the answer is because if I wanted it to move up to 10, if I wanted to actually move up to 11, I'd have to add 1 additionally to it. But by multiplying it by 11, that includes 0 through 10, and it stops at 11. Okay. Remember, this is going to be the range to 11. Which of the following would be true about 75% of the time? Is if you pick a random number above 0.25. A random number below 0.25 would only occur 25% of the time. And this is very similar to the last, I guess, the first example, where it would be very low percentage chance that we'd actually get 0.25. All right, completing this problem, it says, which of the following statement assigns a random integer between 25 and 60 inclusive? Now, if we look back at our formula, well, let's look at our numbers. We have 25 to 60, right? Our formula, we look at the max number, 60 minus 25. So 60 minus 25 would give me 35, plus 1 would give me 36. So that's why this number on the inside would be 36. Plus whatever the minimum number is, the minimum is 25. So that's why this is my answer. Once again, the way I got this answer right here was by using this formula right here. The max number minus the min plus 1. Okay, the max number was 60 minus 25, gave me 35, plus 1, gave me 36, and then I added the minimum value 25 there. Okay, these are some other math functions that you can use. Okay, you can use absolute value, which we mentioned briefly. The absolute value of a double returns the absolute value of a double value. Okay, PAL, which returns the value, the first parameter is raised to the power of the second. So if you wanted 9 to the third power, you would write PAL 9, 3. And that will do that calculation for you. Okay, math.pal. Okay, math dot and then sqrt for square root gives you the square root. You pass in a double. And we just talked about random. These are all listed on the AP quick reference sheet during the exam that you can use when this does become an AP class. All right. 2.91 says programming challenge random numbers. It says you may have a combination lock on your locker at school. We don't have lockers anymore, where you have to spin the dial to 3 separate numbers from 0 to 40. What if you forgot your combination? Would you be able to guess it? Okay, and that would take a certain permutation in order to calculate this. Some of you guys may have taken statistics or taken, I guess that would be in the second half of Honors Algebra 2, permutations and combinations. Okay, it says write code that will generate 3 random integers from 0 up to 40, but not including 40. Using Math.random in the active code window, run below. Okay, run a couple times to see if it generates, run it a couple times to see it generate different numbers. So that's the first step. Okay, so write code says use Math.random to generate 3 integers from 0 to 40. Okay, so if we remember correctly, right, I'm going to go ahead and just copy this, right? We are multiplying. I'm just going to go ahead and copy all this. So that way we have it referenced and I can talk about it without moving back and forth, right? I'll go ahead and paste it. And I'll go ahead and put that there. And I'll put that right there. Okay. And once again, I've copied and pasted this in here just so we can use it and use it frequently. So we're trying to find 3 integers from 0 to 40. Okay. And we used before, if we were going to go ahead and import, if we look back at our previous example, we were able to use Math.random without importing anything. So we don't need to import anything. We can use it by going through here and writing some code. If you look at, in the beginning, we've created an integer and we give it a random number. Okay, or sorry, we give it a name. In this case, we said Rn for random number. So we're going to go ahead and create a variable here. Let me go ahead and just call this, I'll call it rand1 because it'll be the first random number that we create. Okay, so we're going to cast this as an integer, and we're going to write math.random, and then we're going to multiply it by whatever the range is. All right, and we're going to take that and multiply it by math.random would be multiplied by the range, which would be the max number minus the min number plus 1. So the max number, right, our max number in this case would be 40. Okay, the min number that we would want is 0, I believe. What did it say? From 0 to 40. Okay, 0 to 40. And we want to add 1 to it. So 40 minus 0 plus 1 would give me 41. Okay. Then from there, I want to go ahead and close this. And let me just print this out and make sure we've done this properly. System.out.println and end of a semicolon. And let's print out rand1. Let's see what runs. Oh, my semicolon. Okay, so we get 26. It runs and we get 26. Now, if we're using this example, right, and we were to run it again, a random number, it would pass would be 3. We do it again and it passes 2. So I'm going to need to create 2 other random numbers because we want 3 random numbers. So I'm copying my code. I'll say random number 2, random number 3, and then I'm going to print out all of this 2 more times. So rand2, rand3. All right. So yes.
So when it goes to Math.random, it goes from 0 to 0.99.
Yes.
And then it times it by 41. It says we can't let it include 40.
So we don't want it to include 40. All right. So if we don't want it to include 40, then we'll just drop this down 1. So really our range would be 0 to 39 plus 1. And 39 minus 0 plus 1 is 40. Okay, so good call there. What we determined there was in the directions, it's saying not including 40. Once again, my inability to read. Okay, so we're not including 40. So we're just going to multiply it by 40. Let's go ahead and run it and see what happens. Okay, so we have our 3 random numbers. We've multiplied it by 40. As we determined 0 through 39, or sorry, 0 through 39 instead of 0 through 40. 39 minus 0 is 39 plus 1 gives me 40. That's why we're multiplying it by 40 here. All right, good call. Now, the second part of this, okay, it says how many times would you need it to run in order to guess your combination correctly? Okay, let's have a look, or let's have the computer. Let's have the code compute the number of permutations possible in your combination lock using math.pow and then the number raised to an exponent. For example, if you had 2 dials on your combination lock where each dial can be between 0 to 9 or 10 different digits, there are 10 to the second power possible permutations. Okay, this would be written 10 2. Now that would be if we had 2 dials on the combination lock. Okay, now it says if you start listing all the permutations possible, you can tell that there are 10 squared or 100 possible permutations for a 2-dial lock. But we are actually looking for 3 dials. So it has 3 dials with 0 to 40, not including 40. Okay, in general, the formula to use is numbers per dial, which is 10, right? Then number of dials. Okay, so write this using math.pow method in your code and save it into a variable and print it out. Okay, so we went through and calculated already our random numbers. Let's see if we can actually write this to solve our problem. Okay, what are different combinations? So the numbers per dial, all right? The numbers per dial as you're going through 0 through, okay, we have 3 dials and we have 0 to 40. So the possible numbers are 40, all right, and then to the third power. So let's go ahead and try that. So we'll have math.pow and we'll say 40 to the third power. And let's make this, create a variable. We'll make this an int and we'll call this, I'll say possibilities, POS for possibilities. And then we'll print that out, system.out.println, and we'll print out how many possibilities there are. And let's run it. It says incompatible types, possible lossy conversion. Let's take a look at what we need to do here. It's saying casting it as an integer rather than the double. All right, so if we were to take this and cast it as an integer, well, we're already writing this as an int here. So I don't know, let's try that. And there we go. Okay, so casting this as an int, math.pow, if you remember, refers this back to a double. Math.pow accepts a double, and then also for the first parameter as well as the second parameter. Since they're both doubles, you do have to explicitly cast it as an int, as Daniel mentioned. And down here, we end up getting our answer, okay? So we've successfully written over 2 lines of output. We've determined 40 to the third power. We've printed that out by using this math.pow method, okay? The first number entered is going to be what number is going to be raised to the second number. Okay, so we can go through and do that. I'm going to skip past that right now, just because I'm trying to squeeze everything in for this period. I'll go back to it, but I'm just going to skip past this because that's just application. This is a summary of everything we've talked about. All right, so all the different methods that exist within the math class. There are many more, but these are just some of the popular ones and the ones that are included on the Java quick reference sheet during the exam. Okay. An important thing to just identify, it's not something we're using frequently, but our range is going to be calculated by taking the max number, subtracting the min number, and then adding 1 to it. Okay, we did that in several examples previously. All right, if you would like to go through and complete this, that's fine. I'll go ahead and I'll add on to this separately and I'll take my time going through it. I just don't want to rush through and then not get through it all. So I'm gonna go ahead and get started here. And just a recap, right? This last bit that I danced over, I'm reading at the same time. I probably shouldn't do that. The dancing turtles, mini little project, I guess you want to call it, that we were working on. I skipped over this and I wanted to jump back to this just so that way we're not missing anything. But what we would do is, or what we're doing is, we're creating a program where it says complete the random numbers using Math.random in the correct ranges to choose XY coordinates, and random color in the range of 0 to 255 for the turtle. It says, and then from there, your turtle will dance. So we skipped over this last time, but I just wanted to go back to it. And if you remember, we were talking about random numbers and the random number generator that we used last time was from the math class, and it wanted us to convert that from a double to an integer. So just to remind you of where we were, okay, we were using something like this where we were creating some sort of variable, okay, and then we named the variable, and then we were casting whatever the random number was, we were multiplying it by a certain number and then adding a number afterwards to that. And the reason why we were doing that was because the range is calculated via the max number minus the min number plus 1. So if you wanted to find the range of numbers from 1 to 50, okay, you would take the max number 50, subtract the min, which is 1, so it would be 49, and then you'd add 1 to it again, which would give you 50. All right, so by using this is what we're going to use to find a random number via the range, and it gives us the range down here as well. So we want a random number. We're going to cast it as an int, okay, and we're going to say Math.random, and just to once again just show you what we're using, I just want to be specific. Inside of here would be the max number minus the min number plus 1. And then on the outside, we're adding the min. Okay, so the max number, it says, would be 480. So whatever that number is, the max number times 480 minus 20. 480 minus 20 is 460. Plus 1 is 461. Okay. And something that it wants us to do as well is it says int random y. Okay, we're selecting a number, casting as an integer. And it says we'd also adjust for 20 pixels on the side. So instead of 0 and 400, it would be between 380, 20 to 380. All right, and we'd still use Math.random, and we're multiplying that by 380 minus 20 plus 1. So 380 minus 20 is 360 plus 1 is 361. All right. Remember as well, when we were going through this, we have to make sure to include parentheses in the proper spot, okay? Making sure that if you're adding on the outside, whatever the minimum number was. So we added outside of that, we added the minimum number. So let's go back to each, making sure what we have is inside parentheses. These are inside parentheses. And then at the very end, we're going to add the minimum number. And the minimum here was 20. And the minimum here is 20. All right. And then all our code ends up happening down here. Now we're selecting more random numbers. I'm going to go ahead and copy our code. It says you can choose a random red, green, or blue value, 0 to 255. So 255 minus 0 is still 255, plus 1 is 256. And the minimum value is 0, so I'm not going to add 0 to it. I'm just not going to include that on there. Okay. And I'm going to go ahead and copy and paste this down here as well. And let's see what ends up happening. Let's see if I ended up making any mistakes. I see a couple semicolons I need to add there. Let's see what happens. And it looks like our turtle changes colors. and moves in a certain direction and continues to move through. I believe we scheduled this 10 times, right? It runs 10 times. So let's look at our code and just try and understand what just happened here, right? We wrote some code, but let's look at it. We have our main method. We created our world. We created a turtle called Yertle and put it inside the world. This for loop, you don't have to understand because we haven't actually talked about loops yet. We just need to know that it loops through 10 times. Loops make things a lot easier when we start talking about loops here in the next few weeks. Loops will allow us to limit the amount of code that we write. And it says we wrote code that allows us to pick a random X position. It moved to a random X position and a random Y position. Okay, making sure that it didn't go off the screen. That's why we subtracted 20 from all around. That's why instead of 0 to 500, we use 20 to 480. And instead of using 0 to 400, we use 20 to 380, making sure it didn't go off the page. Okay, and then we made the turtle move to the random XY coordinate. It turned right. So remember, turn right turns at 90 degrees. And then we selected a random color, RGB, from 250 to 255. And then we set that color to the turtle. All right, and then it went through 10 times. So once again, if I run this, see how this pattern we have down here, it looks like that. It's not going to be the same pattern here because we're using random numbers. And also they'll use different colors. All right. So it turns 90 degrees and then moves to a random position. That doesn't mean the angle is at 90 degrees. That just moves us the way the turtle had turned and then moves to a 90 degree, or sorry, moves to a random location. All right. So we completed that. We already talked about everything else in the summary, but I wanted to make sure that we went through that. All right. And that's 2.9 using the math class.